volcano ready to blow? Well, wait a minute. First, let me just break in here for a minute. Thank God I took my GetTheT.com with me on the road this time. Are you serious? Are you serious? Came down with a little bit of a virus. Seriously, I was preaching Saturday night, Sunday morning, Sunday night. If it weren't for some soothing tea and honey, what? I may never have got through this weekend. Folks, check out GetTheT.com. It's a great company, a Christian company. Ronnie McMullen just does a great job. It's not only with his tea, which is fabulous. His tea is the best tasting tea ever. And I'm not saying that to be joking around. I'm dead serious. Great tea, but it's organic, it's healthy, and it gets the toxins out of your body. Wow! Thank you, Ronnie, for doing a great job with GetTheT.com. Plus, he's got other supplements. You can check that all out at his website at www.getthet.com. All right. Now, we need to really do some praying for the folks in Bali and Indonesia. It is rumbling. It's rumbling. It's rumbling. This thing is thundering and thundering and thundering. It is about ready to blow. We've been worried about it. We're in our 40-day warning. We've had 2 massive solar flares. We just had another solar flare eruption on the sun. Hurricane Harvey, Hurricane Irma, Hurricane Katia, Hurricane Max, Hurricane Jose, Hurricane Maria. I mean, what else can we have here? Texas was hit, Florida was hit, Puerto Rico was hit, and then the 2 killer earthquakes in Mexico, the super volcano at Yellowstone's rumbling, and the forest fires burning out of control on the West Coast and in Canada, and now Indonesia. And I'm not even going to talk about Kim Jong-un wanting to go boom, boom, boom. No. But we really got to pray. Here's what's going on in Indonesia. They've put travel warnings out now from Australia and Singapore. Fears that the volcano could erupt is imminent now on the holiday island of Bali. Promoters are actually, it's prompting several countries to issue travel warnings, while Indonesian authorities are literally racing to evacuate tens of thousands of people living in the danger zone. That's what they're calling it. I'm reading right off the article. Australia, New Zealand, Singapore, the United States, the United Kingdom have all issued advisories on travel today. And today is what? Unbelievable, folks. It's the 36th day of the 40 days warning since the total solar eclipse of the sun on August the 21st. 40 days of repentance. God told us there was a warning, apocalyptic events, a warning for the United States and the world. And this is we're in the 40 days here. And at the end of the weekend, the warning that increased that volcanic activity at Mount Agung, in eastern Bali could disrupt flights at one of the world's most popular tourist destinations. And given the possibilities of the eruption, the Singaporeans should defer non-essential travel to the affected areas at this juncture, says their foreign ministry online in a statement. Now, Bali's international airport was operating normally today as tourists were spotted across the island, but Indonesian authorities have imposed a 7.5-mile exclusion zone around the crater. The National Disaster Management Agency said today that around 62,000 people live within the danger zone around this volcano, and that they all needed to get out of there, to evacuate immediately. 62,000 people. So far, 50,000 had moved temporarily into shelters provided by neighboring villages. Folks, if this thing blows sky high, though, even those shelters would not be protected. So the danger zone is if there's an immediate eruption, but if there's a massive eruption, a mega eruption, then we're talking about something totally more catastrophic. This could become a cataclysmic event. Our prayers are going out. The national, there are some people who stayed behind because the volcano hasn't erupted yet or because of religious beliefs, they're not going to leave, okay? So our prayers are going out to all the folks in Indonesia, to everybody. Seriously, we're praying for all of you. Be safe out there and heed the warning and get away from the mountain. Get away from the mountain. It's going to blow. It is inevitable. It is going to blow. It's in a critical phase, according to seismologists, and we're going to watch very closely. Now, some would say Planet X, that Nibiru, that this magnetic gravitational pull, really, that's heating up the core of the earth, is causing all of this volcanic and earthquake activity, and even this unbelievable amounts of hurricanes that are affecting the earth. So, biblical signs told us this would happen. Jesus said, there shall be signs in the sun and in the moon and in the stars, and distress of nations with perplexity, the sea, the waves roaring. Men's hearts would fail them for fear, for looking after those things coming upon the earth. For the powers of heaven shall be shaken. Then shall we see the Son of Man coming in a cloud with power and great glory. So when these things begin to come to pass, he said, look up, lift up your head. Your redemption's drawing nigh. And we know we're getting close, folks. We're getting very, very close. Are you saved? Give your life to Jesus Christ. It's going to blow.
For 4 billion years, their fires and ash have impacted life on Earth.
It's moving this way. Get out. It is coming.
Civilizations have been decimated. Empires destroyed.
This was really a giant eruption. It vaporized a culture.
And yet, they have allowed life to flourish.
Volcanism is constantly recycling the surface of the Earth.
Today, through modern science, volcanoes have unraveled a different kind of wisdom about life on Earth.
Humans are nothing else than volcanic products.
How have they shaped world history? What have they done to the Earth? We look at history's most dramatic eruptions, traveling through time and through different continents. We take you on a journey deep inside the volcano. From space, high above the skies, the Earth is a serene blue. But up close, it is anything but that. Over the plains of Wyoming, a powerful volcanic blast occurs. 1,000 cubic meters of ash and lava are thrown into the atmosphere, plunging much of the United States, Canada, and Mexico into darkness and impacting lives worldwide. This is the eruption of Yellowstone, a mighty volcanic crater right in the heart of America. And it can happen.
Yellowstone is capable of having eruptions that will really be devastating, perhaps for the whole United States, have effects around the globe. Perhaps for many years, the temperature of the Earth might change for a dozen years or more.
Well, imagine a volcanic eruption thousands of times bigger than Mount St. Helens. Farming, agriculture, livestock would be killed, agriculture would be terminated for many years, and that's the breadbasket of the world.
Scientists don't know for sure when exactly Yellowstone will erupt, but it's a possibility nonetheless. Yellowstone will change the world when it erupts, and that's not new. Throughout time, volcanoes have caused widespread disaster and changed the course of history. Why are they such a menace feared by man? And what exactly are they?
A volcano is really a crack in the ground, a deep crack. out of which comes material that's generated, melted material that's generated below it. We call this magma. And the magma comes up through the crust of the Earth, and through the crack, it's released.
Each year, around the globe, approximately 50 volcanic eruptions occur, some more devastating than others. These eruptions were once viewed as divine wrath. Today, science guides our understanding of what makes a volcano and why the Earth is so dependent on them.
Much of our atmosphere that we're currently breathing is a consequence of volcanic eruptions that took place 3 or 4 billion years ago. They actually provide an insight. They're a window into the Earth.
Each active volcano is a ticking time bomb. A bomb that gives out warning signs in mere days, if not hours, before its blast.
Before an eruption occurs, you would expect to see certainly increased seismicity, lots of earthquakes as magma is breaking rock as it moves towards the surface, and also the ground deformation. As magma accumulates beneath the surface, you would expect to see the volcano's surface start to inflate like a large balloon.
But a volcano's eruption is only the final stage of a long process that begins hundreds, if not thousands of years before. There are several ways in which volcanoes are formed, and to understand this, we need to go deep inside the volcano.
If we look at the planet as a whole, it has an inner core and a mantle that makes up most of the volume and mass of the planet, and a very thin veneer or shell around the outer surface is called the crust.
Beneath the Earth's outer surface, layers of rock make up continental and oceanic plates. These plates continually shift at a rate of a growing human fingernail. Over hundreds and thousands of years, they push against each other. There are several large continental plates that are moving toward each other. They include the Pacific Plate, Australian, Eurasian, North American. When two major continental plates collide, the denser and heavier plate will be forced to go beneath the thinner one. This process is called subduction, and this causes the first type of our volcanoes, continental margin volcanoes. The mountains of America's Pacific Northwest, such as St. Helens and Rainier, are examples.
What happens in subduction zones is that one plate goes underneath another, and the plate subducts. That's why they're called subduction zones, and the material melts and comes up as magma.
Not all volcanoes, though, occur as a result of the clash of two plates. Our second type of volcano is formed beneath the ocean. Hot mantle rock from the Earth's core rises and builds on the ocean floor, creating islands. This area where the lava rises is called a hotspot, and volcanoes formed by this process are called hotspot volcanoes, such as those in the Hawaiian Islands.
Which is essentially a plume of very hot material that originates somewhere deep within the Earth and flows upward and burns through the Earth's crust and sends magma essentially right to the surface where a volcano is formed. As a plate moves over a hotspot, the hotspot punches through the crust.
Our third kind of volcano is formed when the Earth's oceanic plates move apart from each other. When they do, they create a series of fissures or openings. If this fissure is situated over a hotspot, magma then rises in between the plates. These volcanoes are called ocean ridge volcanoes. The volcanoes of Iceland fall into this category. They are not conical in shape, but long ridges that stretch for thousands of miles. If two adjacent plates clash under the ocean, they cause the formation of another type of volcano. These volcanoes occur not at the point of contact of the two plates, but about 60 miles away. These are known as island arc volcanoes, and they form a chain of volcanic islands. The volcanoes of Indonesia, like Merapi, Krakatau, and Tambora, are classified as such. These four settings create the different types of volcanoes we see on our planet today. Because each type of volcano is formed differently, this affects the type of eruption that occurs.
Volcanoes come in different types, and I like to think of them as having different personalities. Some just bubble away very quietly, some are very explosive, get very angry.
There are several types of eruptions. Gentle flowing ones are called Hawaiian. Strombolian eruptions are those that send lava flying into the air. Volcanian eruptions release much gas and ash. And finally, the most violent type called Plinian. This eruption features a loud burst of ash, gas, and rocks.
Now, why are volcanoes different over the Earth, and why do they predominantly have one type of eruption or another? And that all has to do with the type of magma that they erupt.
The contents of the magma chamber dictate how the volcanoes behave above ground.
As one descends into the Earth, the temperature increases at a rate of about 15 to 30 degrees Celsius per every kilometer of depth that one ascends. What that means is there'll be localized heat zones where the rocks have expanded. They're all very hot. They're under great pressure because of the weight of all of that rock above it. As these magmas approach surface, the confining pressure becomes less and less, and the gases tend to come out. A good analogy for explaining the behavior of dissolved gases in magma is if we look at a bottle of seltzer water. What we have is a bottle with a liquid that fills most of that container, and a little bit of air above it with a cap on top. When I pop the cap on the bottle, we hear a hiss. That represents the fact that there was an extra pressure of carbon dioxide mixed with the air above the liquid in that bottle. Opening the bottle, the pressure on the liquid inside decreases, and at that instant we see bubbles appear throughout the liquid. Magmas in the Earth behave much the same way. They're molten rock, it's a liquid, they contain dissolved water and carbon dioxide.
The contents of the magma also affect how volcanoes behave. In these magma chambers, there are molten rock, gases, and various mineral crystals. Temperatures here can reach as high as 2,000 degrees Fahrenheit. When the volcano erupts, what comes out are ash and soft white rocks known as pumice.
Pumice is lava that's so full of bubbles left behind by the gases that have escaped the lava that it's almost like a sponge, spongy rock. And a piece of pumice is so light, there's so many holes in it, that it will float on water. And so it's really kind of a froth of magma that is blown out of the volcano and solidifies as it's blown out. It's a kind of spongy material.
All these simmer underground like a thick pot of stew for many years. When a volcano finally erupts, it empties the contents of the magma chamber. What's been simmering for hundreds, if not thousands of years, is suddenly unleashed in mere hours. And yet, their impact is often felt decades later, thousands of miles away. With just one cataclysmic blast, volcanoes have the audacity to change the course of history. One of history's most devastating eruptions occurred in Europe more than 3,600 years ago on the Greek islands of Santorini. This volcano erupted with such fury, it triggered the decline of a civilization.
This was really a giant, enormous eruption. It essentially vaporized a culture. That must have had a big influence on everybody that lived in this area. I think it changed the course of Western culture.
In the wide expanse of the blue Aegean Sea, a group of islands stands out in the Greek archipelago. Their dark and brooding nature appear in contrast to the white limestone and pristine marble of the rest. These islands are collectively known today as Santorini. More than 3,600 years ago, a mighty volcano sat at the center of these islands. Its name? Thera. Around 1600 BC, a powerful explosion rocked Thera. The volcano erupted with much fury. Ash, rocks, and pumice were thrown into the sky as high as 23 miles, blanketing the skies and darkening the ancient world.
Let's think about how big this eruption was. Let's compare it with something we're familiar with. Let's compare it with Mount St. Helens, 1980 in the United States. That eruption, we think, was a big eruption. This eruption was 100 times that explosiveness. It started off with pumice being thrown out, ejected. There's a rainfall of pumice piling up everywhere, plop, plop, plop. And that piled up very quickly to produce the first layer, or the first phase. Then comes the second phase. Suddenly something changed. Suddenly it went from the pumice flying up into the air and plopping down, piling up on the ground, to something that went zoom across the level of the earth.
This fast-flowing ash and pumice that hugged the slopes of the mountain is called a pyroclastic flow. Traveling at speeds of 100 miles per hour and with temperatures up to 1,000 degrees, the flow is deadly, destroying all in its path, burying everything within sight. When Thera erupted, the cities surrounding the volcano were destroyed. Only in the last 50 years have archaeologists found clues about the extent of the eruption. In 1967, Akrotiri, an ancient city in Thera, was discovered, buried under layers of volcanic ash. A lost city was found. But how about a lost continent? Could Thera's eruption be responsible for something greater? Perhaps the sinking of a legendary island empire known as Atlantis. The eruption of Thera in the Greek islands around 1600 BC destroyed the nearby city of Akrotiri. But that's not all. Far worse, it impacted civilization and history. Scholars believe that Thera's eruption changed the whole course of Western civilization. It precipitated the downfall of a people known as the Minoans. Their seat of power lay 75 miles away from Thera on an island known as Crete.
Crete is a very fertile land, very productive, and affluence characterizes it throughout its history.
The Minoans were the contemporaries of the mighty Egyptians with a language of their own and a culture revered by others. They were peace-loving traders who placed strong emphasis on commerce and not war.
It was a commercial empire. It didn't have any defensive walls or anything to protect themselves because they had the ships for that, the boats for that. And so they were known all around the entire Eastern Mediterranean as traders.
Highly cultured and civilized, the Minoans held much promise as a people. It was their culture that provided the seed of Greek civilization 1,000 years later. They had an advanced state of bureaucracy and organization. Today, the only things that remain are the palaces and ruins where tourists flock each summer. The fall of the Minoan civilization could be traced back to a single natural disaster: the eruption of Thera.
This is Knossos, the major palace, the major settlement for the Minoans on Crete. What did they see one morning when they woke up? What they saw on the horizon there was a volcano erupting. It was erupting with the largest blast we know of in human antiquity in this part of the world. They saw a gray sky, a black sky. They saw lightning. They saw darkening clouds enveloping them and ash falling on the ground all around them, and earthquakes, constant earthquakes. For them, the world looked like it had ended.
Ash from the eruption traveled from Thera to Crete in less than half an hour. The Minoans in Crete had no idea what was in store for them.
Imagine you're on Crete, you're a Minoan. Life is going on very nicely. Suddenly, north of them, on the horizon, something blows up. And they know it's an island. And they probably have cousins that live there. Suddenly, it's just in 4 days, just everything breaks loose. There's fire in the sky, and there's tsunamis smashing into their coastline, and there's ash falling out of the sky, and probably even torrential rains that came along with the latter part of the eruption, and earthquakes. That effect on them must have been tremendous. If a climate change accompanied this eruption, then that climate change influenced their agriculture for a while.
The volcano brought a lot of pumice, and pumice is a material that floats very easily, and it covered apparently most of the eastern Mediterranean for years, making rowing or sailing, of course, impossible. So this commercial empire lost its major part of existence.
Earthquakes from the eruption triggered fires, setting ablaze the Minoan palaces. But beyond physical devastation, there is a greater effect: the self-confidence of a people. This marked the start of a 50-year decline of the Minoans.
Did the volcanic eruption on Santorini directly destroy the Minoan culture? The answer is simply no. If, however, we ask a more subtle question, did it contribute to the decline? Did it undermine Minoan power? The answer is almost certainly yes. The chances are that anybody faced with that sort of devastation would ask, what is going on? Are the gods displeased? And such questioning, such undermining perhaps of the social fabric could have led to all sorts of expressions within Minoan culture.
With this breakdown of social order, the Minoan civilization ultimately suffered a blow. Only remnants of their glory are left behind.
It's interesting to speculate what civilization would have been like if the Minoans had not declined. So perhaps if the Santorini eruption had not happened, the history of Greece as we know it now would have been very different.
What caused Thera's eruption to be so far-reaching? For answers, we have to go deep inside the volcano. Thera sits on a string of volcanic islands straddling 4 plates. This convergence of plates creates the chain of volcanic islands and makes Thera's eruption highly potent. Magma is formed when the African plate gets pushed beneath the Eurasian. The result is a gas-rich and thick magma that erupts explosively. Today in Santorini, scientists are still trying to understand. Archaeologist Floyd McCoy has dedicated more than 20 years of his life to studying the impact of Thera. He believes the explosion was so loud it could be heard throughout southern Europe, northern Africa, and the Middle East. More importantly, the blast completely changed the shape of the land. Thousands of years before the Minoan eruption, Santorini was believed to have joined as one, possibly shaped like this. After several eruptions, that single island was blasted apart into smaller ones. At the time of the Minoans, a volcano named Thera sat in the center of these islands. When it erupted around 1600 BC, it again changed the shape of the islands.
One of the effects of volcanism is that the scenery constantly changes through time. With every eruption, it changes, it gets different, it looks different.
When Thera erupted, it unleashed a powerful force into the sea. Scientists believed it caused giant waves or tsunamis that battered the Aegean coasts.
This eruption produced all kinds of physical effects in this area. Dozens of tsunami produced. And then what happens is that the center of the volcano, after it's been blasted, collapses to produce today's caldera. And just think of that. The land just suddenly falls in. The ocean's there. The ocean pours in, pours out. Tsunamis again. The impact has got to be huge, tremendous.
Today, all that remains of the volcano is an island in the center of Santorini called Nea Kamenni. With the birth of this new island, the volcano is slowly rebuilding itself.
And over the next 20,000 years, this island is going to get larger and larger, and then possibly explode again. That's the history of this volcano. Repeated explosions about every 20,000 years.
The Minoan eruption that happened circa 1600 BC was enormous. Legends have been linked to this eruption. They've suggested that another island empire was also devastated by Thera's powerful blast. A mythical continent described by the Greek philosopher Plato, known as Atlantis.
According to this legend, a whole island was destroyed and it was submerged in one day and one night.
Did Plato, was he really passing on something that was real? That's just hard to know. Did a landscape disappear? Did an island disappear?
Whether or not this theory can hold, the answer lies deep beneath the sea. For the Aegean is an expanse filled with history's little riddles. Indeed, myth and science seem to be strange bedfellows here in Thera. With few written records as their guide, scholars often have no choice but to use legends as launching pads to their study.
When volcanologists are trying to reconstruct an ancient eruption, you use everything you can, all the data you can. And certainly there's a lot of collaboration between volcanologists and archaeologists and historians. And in Santorini, for example, that has been a great collaboration because the archaeologists can tell us things, help us date the eruption, while the scientists that study the effects of the eruption and the sequence of events can say something else. So you end up tying it all together, and you even look at legends and stories such as Atlantis because perhaps they were inspired by this eruption.
500 miles away from Thera, the majestic pyramids of Giza stood as a witness to this powerful eruption. The cataclysm unleashed in Thera is believed to have reached here. Volcanic deposits from the blast have been found in the Nile Delta. This has prompted some scholars to suggest that stories in the Bible may be linked to Thera's eruption. In the book of Exodus, signs of the plagues include thunder and hail and total darkness, phenomena that could have been volcanic in origin. And another plague mentioned in the Bible, the waters of the Nile turning into blood.
The Nile water turning into blood. And you ask yourself, how is that ever possible? I mean, why could they describe something like that? What must have happened? Of course, it's quite easy to understand because huge amounts of dust, reddish dust, because the upper layer that you have in Santorini is a pinkish reddish color. A lot of that material actually wiped out over the area of Egypt and was then brought towards the Nile by very heavy rains, which were also falling at the time that you had all this dust in the atmosphere. And so that means that the color of the Nile changed somewhat from the typical sort of yellowish, brownish towards a more reddish tint.
Even today, scientists and historians are trying to piece together the complete story of Thera's eruption. Much of its secret lies beneath the sea, in ash deposits and perhaps sunken continents and lost cities. But there is another volcano whose tale is finely preserved. This was the first time in history that an eruption was recorded in great detail by one man. His is now the name scientists associate with the most explosive of all eruptions.
Even in the middle of what must have been chaos, he described the eruptions and the events of the eruption in a very detailed and very scientific way.
Can a volcano be so explosive that its legacy is felt more than 1,000 years later? The eruption of Thera, a powerful volcano circa 1600 BC, changed history and geography. Almost 2,000 years later, another volcanic eruption rocked the civilized world. This was an eruption famous in history because of an eyewitness account, the first time in history that the stages of an eruption had been detailed. Rising 1,300 meters in solitary splendor above the Bay of Naples, it is the only active volcano on continental Europe. In August 79 AD, Vesuvius erupted, burying the surrounding Roman cities with ash and rocks.
That day, it must have been hell. Day turned into night because of eruption clouds, cutting out the sun. There would have been a tremendous smell of sulfur, and the people must have been terrified and not knowing what to do.
Over a period of 30 hours, the people who lived in cities surrounding Vesuvius watched in awe of this eruption.
The 79 AD eruption of Mount Vesuvius began on August 24th with an initial eruption of about an inch of ash, a couple of centimeters. That was followed by the eruption of pumice, and that is gas-charged volcanic glass that's still extremely hot. And basically, it's gas-charged magma that's puffed up, much like puffed wheat represents a little kernel of wheat. This stuff is very buoyant, was thrust high into the atmosphere, and started raining down.
This eruption was equal to 500 times that of the atomic bomb in Hiroshima.
That is a consequence of a high concentration of gases dissolved in the magma. Interestingly, the magmas at Vesuvius have erupted very gas-rich materials over the last 25,000 years. It's the presence of these gases that expand and provide the driving energy, just much like steam in a turbine is used to provide electrical energy. The gas expanding in magmas erupts very catastrophically.
A cloud of ash and pumice known as pyroclast was ejected into the air, forming a tall column. This pyroclast stayed in the atmosphere, but not for long.
The cloud of material rises up above the volcano, but it sometimes becomes so dense that parts of the cloud collapse.
The flow reached the city of Pompeii first, traveling at speeds of up to 200 miles per hour and at temperatures of between 200 to 800 degrees.
In addition to the high temperatures and the high energy of impact of the flow, is the fact that really the particles in it are heated volcanic rock, but largely volcanic glass. So this is minute particles of fine-grained, hot, gas-charged glass that when breathed would literally choke someone, being clogged in their windpipe.
Everything that stood in its way was destroyed. Herculaneum soon followed. Both cities buried under the pyroclastic flow, silenced for the next 1,800 years. Scientists know so much of what happened by studying the layers of rock. Each grain of dust is able to tell Mother Nature's story in detail.
We are looking at the deposits of the AD 79 eruption of Vesuvius. It is very interesting to look at these rocks because looking at the texture and the composition of these deposits, it is possible to understand which kind of phenomena occurred during the eruption and which kind of damages they caused on the buildings inside the town of Pompeii. The first part of the deposits, composed of these fragments, very light fragments of stone, means that during the first phases of the eruption, these stones fell down like and like a snow. They covered all the city of Pompeii.
The eruption that occurred that fateful day in August of 79 AD took many Romans by surprise. Most of them never knew that something so beautiful could be so deadly.
Romans didn't know that Vesuvius was a volcano because it was a very quiet mountain for about 7 centuries. These lands were very quiet places. All the flank of the volcano were cultivated with grapes,
It was a very nice and green place.
At the time of the eruption of Vesuvius in 79 AD, the pantheon of Roman gods held sway in the empire. Natural calamities were explained not by science, but by divine acts. The volcano is thought to be the home of Vulcan, the blacksmith of the Roman gods.
The ancient Romans knew about some volcanoes. They thought that the god Vulcan was there at his forge, and he forged Jupiter's or Zeus' thunderbolts. And when he banged on his anvil, that's when the explosions happen.
Inside his world, the volcano is the entrance to the underworld. This is akin to hell for the ancient Romans.
If you look, for instance, at present-day eruptions, you see this enormous cloud going up and swirling up into the atmosphere, and sometimes even higher into the stratosphere. Then it's very easy to see giants in there. Faces and limbs and you know, bodies and so on, and it is as if they are swirling around each other and fighting with each other. And a lot of times that sort of image came through in the mythology and says, look, yes, these were giants that came from under the earth. They were fighting with each other once they were freed and came towards the surface.
But not all Romans, though, were guided by mythology and superstition. Many Romans, especially educated ones, had scientific pursuits. A written account of the eruption of Vesuvius by one young Roman from the nearby town of Misenum gave birth to the science of volcanology. Caius Plinius Secundus, or Pliny the Younger, had observed the eruption from a distance.
He was able to describe the events very, very clearly, although a number of years afterwards, after he had thought about it very carefully, and actually took different aspects of them and linked them together.
Pliny the Younger was a real scientist. Even in the middle of what must have been chaos, he described the eruptions and the events of the eruption in a very detailed and very scientific way. And that has really helped us reconstruct what happened on that day.
This became one of the first eyewitness accounts of a volcanic eruption in history.
A cloud was forming. Its appearance and shape would be best expressed as being that of an umbrella pine. Since stretched upward like an extremely tall trunk, it then spread out like branches. I think it first rose up, originating from a stream of air, which then abated, so it gave way to its own weight, spreading out slowly. Sometimes it was white, sometimes dirty and blotchy, because of the soil or ash that it carried.
Because of the records of Pliny, today we have a better understanding of how volcanoes behave. In the laboratory of the American Museum of Natural History, volcanologist Jim Webster builds upon this scientific observation that started with Pliny. With just a splinter of a rock taken from Vesuvius, he's able to piece together clues of the historical eruption. And with that, the explosive nature of the volcano is revealed bit by bit.
Our scientific understanding of volcanoes and of volcanism, the process of volcanic eruption at the surface of the Earth, is constantly changing. It's largely a function of having the opportunity to observe active eruptions.
On the grounds of Vesuvius today, volcanologists like Sandro de Vita are studying its dynamics and structure. The question that confounds scientists: what causes one volcanic eruption to be more explosive than others? To understand this, there's a need to go miles deep inside the volcano. Vesuvius sits atop two continental plates that collide with each other, the African plate and Eurasian plate.
During this collision, together with the formation of the mountain chain, there was a rotation of the Italian peninsula, an anti-clockwise rotation of the peninsula that stretched the crust, generating many fractures.
These fractures or cracks underneath the Earth provide pathways for magma movement. This is where the magma builds itself up to a highly explosive state.
There are a number of factors that influence the extent of explosivity, the amount of energy that's involved. One of the primary characteristics is just simply the bulk chemistry of the magma or molten rock itself. And viscosity can be described as the ability of a liquid to flow. So we all know, for example, the analogy of molasses in winter is very thick, it's viscous. Whereas when it's warm, it's more runny, so it's less viscous. So with regard to magmas, the issue is a more viscous magma is less likely to expand as bubbles form inside of it. So there's more potential energy built up.
That was what happened in Vesuvius in AD 79. When gases cannot escape, the pressure intensifies within the magma chamber. Over time, this buildup can no longer be contained, and a powerful explosion occurs. When the tall column of volcanic ash and rocks collapsed, it spelled doom for the people of the two cities of Pompeii and Herculaneum. Yet ironically, what the volcano buried in history, it also kept for posterity. How did the history of Vesuvius continue to impact lives thousands of years later? Vesuvius erupted in 79 AD, throwing a tall column of searing ash, rocks, and gases high into the atmosphere. This tall column didn't stay above for long, though. When this collapsed, it surged down the sides of the volcano, burying the cities of Pompeii and Herculaneum.
Of the 20,000 or so inhabitants of Pompeii at that time, approximately 2,000 people unfortunately lost their lives.
Most of the people didn't stay there, and they were not caught by surprise because the earthquake happened first. Around 10% of the people, it is estimated, that stayed in Pompeii and were killed, and they were killed by pyroclastic flows that happened in the early hours of the morning.
Today in Pompeii and Herculaneum, tourists walk through the sites, remembering the day Vesuvius erupted. For generations, the world seemed to have forgotten about the 79 AD eruption. When Pompeii and Herculaneum were unearthed in the 19th century, lost art and architecture were presented to the world. This ushered a new movement known as neoclassicism. Buildings around the world were inspired by the remnants of the lost cities.
There was this whole resurgence, actually, of saying, let's copy it. Both in the literary world as in the artistic world, there was this, you could almost call it an upheaval, but Renaissance is a better word for it.
Vesuvius still remains an active volcano. Pompeii and Herculaneum are long gone, but Naples is a bustling, vibrant city. Since 79 AD, the volcano has erupted 50 times. Most were minor eruptions. Its last was in 1944. 26 people died as a result of that eruption. The flowing lava destroyed nearby towns as well as an American military base. Perhaps for them, the proximity of death exalts life. Surrounding lands are fertile and bountiful. Vesuvius provides an easy intimacy between the destructive and the creative. The volcano has come to embody something more than just a natural phenomenon. It shapes the culture and psychology of the people who live on its flanks. Here in Naples, this is evident. More than 2 million people today live in Naples and the towns surrounding Vesuvius. In the backs of their minds, they know this active volcano will erupt again.
It's considered one of the most dangerous volcanoes in the world because you have a large number of people, in Naples, for example, and all the suburbs of Naples that run around the volcano. and you could imagine the roadblocks and people trying to get away from the volcano. It would be a very, very dangerous situation in which hundreds of thousands of people could be killed.
But they have learned to cope with this permanent threat of living in its shadow. For years, scientists have been campaigning to restrict urbanization around Vesuvius, but their words have fallen on deaf ears. Neapolitans believe that their patron saint, San Gennaro, will protect them from Vesuvius's next eruption.
Naples, along with various other problems, has always had the volcano Vesuvius. The people always pray for the intercession of San Gennaro. In fact, on the east door of the old city, there is a statue of San Gennaro with a hand like this, extended toward Vesuvius, and this is the exact representation of San Gennaro saying to the volcano, "Stop, don't go to the city."
Tortured and beheaded, the saint died a martyr in 305 AD. Today, his remains are interred in a crypt in the cathedral. Drops of his blood had been preserved in well-kept files. 3 times a year, a ceremony is held in the city's cathedral with the blood of San Gennaro being brought out. The time Vesuvius strikes, it is hard to comprehend the tenacity of the people who live at the foot of volcanoes. Why would people risk life and property to live on the flanks of volcanoes? Won't it be easier to live far away from centers of calamities? That, though, may not always be the solution. A volcano's reach may be closer than we realize, even if we live thousands of miles away.
A volcanic eruption can potentially have worldwide reach. It can also influence climate worldwide, and in many cases, several years after the event.
Can an erupting volcano half a world away cause devastation to lives on the other side of the globe? One out of every 10 people in the world today live in areas flanked by active volcanoes. For them, life goes on even as the shadow of destruction hovers in their midst. Many of them live around the Pacific Rim, an area of high volcanic activity known as the Ring of Fire. The collision of the Earth's major plates creates these active volcanoes, from Navidad in Chile to the Fuego Mountains in Central America, to Mount St. Helens in the Cascades of America's Northwest, to the island arcs of the Aleutian and Siberia, to Japan with its venerated Mount Fuji and a ferocious Mount Sakurajima, to Indonesia where Krakatau awaits with Holy Bromo and Mount Tambora.
Along the Pacific Basin, much of the Pacific Ocean crust is being thrust beneath surrounding continental crust. And in those zones, there is constant volcanism taking place. It probably represents 15 to 20% of the volcanism taking place on our planet.
But a volcano's wrath isn't just limited to those who choose to gamble with their fates. The impact of a powerful volcanic eruption can reach thousands of miles away.
A volcanic eruption can potentially have worldwide reach, and the reason being is particularly explosive eruptions can inject ash and gases directly up to the stratosphere, or up to 17 kilometers or more in height. And this material can spread globally, and it can also influence climate worldwide, and in many cases, several years after the event.
An eruption in Indonesia, half a world away, may in fact affect lives in America and Europe. History has already shown this before. The Indonesian archipelago is a sea of islands home to the largest number of active volcanoes.
Indonesia is really a chain of volcanoes that essentially result from the fact that we're recycling some of Earth's older oceanic crust It's part of what makes Indonesia prone to volcanic hazards in that manifestation of this subduction or recycling process.
On the island of Sumbawa, locals call Mount Tambora the Great One. In 1815, Tambora erupted in a series of blasts. 150 cubic kilometers of ash shot to the sky. Darkness lasted for 3 continuous days. From its initial height of 13,000 feet, Tambora was reduced to only 9,000 feet by the end of the eruption. It was estimated that over 10,000 people were directly killed from the blast. Another 80,000 more lives were lost from famine and diseases. Numerous pyroclastic flows hit the surrounding flanks of the mountain.
These came cascading down the flanks of the volcano in a 360-degree pattern about the vent and essentially inundated all of the island of Sumbawa. The 1815 eruption is also notorious for the fact that large amounts of SO2 gas were discharged directly to the stratosphere. So it combines with water to form a compound called H2SO4, and these fine aerosol particles have a long residence time in the upper portion of our atmosphere and can affect climate where we live.
Climates around the globe were severely altered. Temperatures worldwide were lowered, causing a catastrophic impact on climates. Throughout Europe, the summer of 1816 was cold and wet. In North America, it was known as the year without a summer.
One of the most fascinating things, of course, of that volcano in 1815 is that its effects were still felt, for instance, in Europe and North America. For instance, in Connecticut and New Haven, we had actually the firemen called out because the people saw these big, huge red glows on the horizon that didn't seem to go away. And they said, oh, the forest is all burning. Well, that red glowing sort of clouds, of course, are a direct reflection of the amount of dust, the pollution that was in the atmosphere. But more important, in 1816, there was frost in Connecticut in July and in August, severe frost. And that, of course, means that that dust that we had in the atmosphere and all the acidic droplets that floated around there caused an enormous reflection of sunlight, of sun warmth, and temperatures dropped very significantly. I think climate change and the effect it has on agriculture specifically, and therefore on famine, and therefore on epidemics, and so on, that is probably much more important and much more significant than the ashes that fell in the general region itself.
Tambora showed that volcanic eruptions could have a reach far beyond local shores. But even then, the full extent is not known. Few details of Tambora's eruption were left behind by historical records. Tambora left behind few clues, but 875 miles across the Indonesian islands was Krakatau. This volcano had more to share. Krakatau sat between the 2 major islands of Indonesia, Sumatra and Java. When it erupted in August 1883, its blast could be heard in Australia, 2,000 miles away. Shockwaves from the blast circled the world, reaching the Americas 20 hours after the eruption.
This shockwave that was made by Krakatoa went around the world. The 2 waves met each other over Brazil, collided, went back, collided, went back, collided.
Undoubtedly, some of these detonations were produced when pyroclastic flows were coming down the flanks of the volcano, entering the sea, and generating what we refer to as hydrovolcanic explosions. You can think of the magma as a fuel and the water as a coolant. And when you have fuel-coolant interaction, we can have some very catastrophic explosive activity taking place. And some of these explosions obviously reverberated about our planet several times, up to 7 times.
Dust from Krakatau fell as far as 1,500 miles away and remained in the Earth's atmosphere for 2 weeks. Sunlight filtering through the dust particles created spectacular optical effects over 70% of the Earth's surface.
It's a sort of a pattern that's caused by all this pollution. Sometimes you get blue, sometimes you get orange and red and so on. You get a color that's unusual.
Today, we know much about the global impact of Krakatau's eruption. Scientific observations were well documented by geologists around the world.
At the time, the telegraph was an invention that mankind used to communicate globally. And it's one of the first eruptions where we can actually have eyewitnesses recording their accounts of the activity being relayed to people throughout the world.
Krakatoa happened at a very fortuitous time in the history of geology. There were geologists in Indonesia at that time who could observe the effects and the after effects of that eruption.
On a world map, the volcanoes of Indonesia may seem small, hardly a dot in the Earth's vastness. But their might is terrifying, their reach unimaginable. But even worse is their unpredictable nature. Today, science is trying to anticipate these volcanoes. Can the inscrutable volcano be second-guessed? For decades, scientists have been trying to nail down patterns in volcanic behavior. When would each volcano erupt? What would the magnitude be? But answering such questions hasn't been easy. Volcanoes, after all, are unpredictable.
In volcanology, we say the past is the key to the future, because volcanoes will do in the future what they have done in the past. And so if we study those volcanoes' histories and study them accurately and get the timing right, then we can make, I think, very good predictions. But again, where they're unpredictable is in that time window where you would like to be able to say, next Thursday at 3 o'clock, there's going to be an eruption of magnitude, say, VEI 5, a big eruption at this particular volcano. That would allow us then to very precisely say when and where, move people away, let the volcano erupt and do its thing, then people can move back in. At present, what we're faced with is the dilemma of uncertainty.
Volcanologist John Pallister works with the U.S. Geological Survey at the Cascades Volcano Observatory near Mount St. Helens. Today, on the slopes of the volcano, Pallister collects lava rocks that would help shed much light on St. Helens' behavior.
We're here in the 1980 debris avalanche deposit from Mount St. Helens, and we're looking at some of the rocks from that debris avalanche to try to piece together the puzzle of where they came from up on the volcano. In fact, what we've got here is a piece of lava that was erupted about 4,000 years ago at Mount St. Helens. And in fact, it comes from that light patch up on the crater wall. We call it the old Pine Creek Dome. So what we're seeing are big masses of the volcano, which slid down in this horrendous torrent of rock that came down in 1980, the largest landslide in recorded history. So it is really very much like a jigsaw puzzle. What we do is we go through and we map the distribution. We show where they are on a map. That makes a geologic map. Then from that map, we reconstruct where they were on the volcano.
Today, volcanologists at the St. Helens Volcano Observatory are keeping a close eye on any form of seismic activity. On their shoulders rests the responsibility of predicting the next eruption of Mount St. Helens, and to avoid repeating the scale of the last disaster. Mount St. Helens, prior to its eruption in 1980, was a picture of beauty. It is one of 15 volcanoes in the Cascade Range, which starts with Mount Garibaldi in British Columbia and extends to Lassen Peak. The subduction of a small plate named Juan de Fuca under the North American plate creates this chain of volcanoes. In May 1980, Mount St. Helens erupted after 123 years of inactivity. A series of earthquakes began in mid-March, followed by eruptions of steam and volcanic ash. Volcanologists knew that it was just a matter of time that a blast would occur. but they couldn't know how.
Clearly, Mount St. Helens was restless again, and that information was put out to the public. The question became, what was the outcome going to be? And in 1980, that was a tough question. We did a lot of work trying to understand what the volcano was doing. By early April, you could look up at the volcano and see a bulge forming in the volcano.
845.
Magma had managed to come from some great depth, many miles below the Earth's surface. Question is, what's going to happen? Well, the only guide you have is to look at what St. Helens has done in the past.
Historically, St. Helens had erupted from the top, but this time something was different. A bulge was growing steadily on its north flank.
We recognized that with the bulge growing on the north flank, it was possible that that north flank would become unstable and would slide away. And if it did, you would have a large landslide, and we might even uncap the magma that had been rising up into the volcano. And we talked about that, we thought about it, and we said, well, that's a possible outcome. Is there any evidence St. Helens has ever done that before? And the answer was no.
But just to be sure, an observation post was established by the USGS on a ridge just 6 miles northwest of the volcano to monitor this bulge. Scientists then thought it was safe enough of a distance should there be an eruption. But the volcano had other plans.
At 8:32, the north flank became unstable and slid away. It made the largest landslide debris avalanche ever observed in historic time.
As most of you already know, we had a major eruption occurring at 8:32 approximately this morning on Mount St. Helens. It does appear that the northwest flank of the mountain seems to be gone.
When it did, it decapitated the magma that had been rising up into the volcano, forming the bulge. And that sudden release of the weight of the bulge caused it to explode. It exploded off to the north.
Within minutes, a pyroclastic flow of ash, lava, and rocks hugged the slopes of St. Helens and sped through them. Much of St. Helens wildlife was wiped out. 200 square miles destroyed. The size equivalent to the city of Chicago.
Get off the bridge! They're doing it.
How predictable was Mount St. Helens in 1980? Well, very clearly, it gave us 2 months of warning that something was up, but we were unable to predict precisely that on May 18th, the outcome was going to be a huge avalanche, a directed blast.
Look at this, it doesn't even look like the same country. Even the valleys have changed. And nothing matches the map.
Where's Spirit Lake? Is that it over there? I can't believe I've camped up in this area. It doesn't look like any place I've ever been before.
So the outcome there was not perfect, but we learned a tremendous amount, and we were able to let folks know that St. Helens was up to something that had not occurred for more than 100 years.
Learning about the past is key in studying volcanoes. Scientists try to predict the future by uncovering past behavior of a volcano.
No two volcanoes are exactly alike. So in order to understand a volcano, you really need to study that particular volcano, what it's done in the past, what is it likely to do in the future. And we're still learning a lot about volcanoes and volcanic eruptions. We are still learning a lot about how to tell if a volcano is going to erupt, and it's very hard to predict.
The unpredictable nature of St. Helens is why some have pointed to the risk another volcano in the Cascades poses. Just 50 miles north of Mount St. Helens is Mount Rainier. At a glance, its icy caps seem a perfect backdrop for picture taking. But make no mistake, Rainier is a volcano biding its time to wreak havoc.
Rainier is considered the most hazardous volcano in the United States. And why is that? It's not only because it's an explosive volcano, like St. Helens, like the volcanoes in the Cascades, but also because it has glaciers at the top. And that can lead to something else.
The problem with Rainier is that the ash, the volcanic fine material that is erupted from these explosive eruptions, mixes with water in the rivers, and if there are glaciers on the volcano, the ice melts. And so you get mud flows, very rapid flows of mud and water coming down the valleys that surround the volcano.
These mud flows are called lahars. Scientists say this mixture is akin to wet cement that can outrun anyone, burying whole cities in mud. This was what happened to the island of Montserrat in the Caribbean in 1995. The eruption of the volcano Soufriere Hills completely covered Montserrat. Thousands of people had to abandon their homes. Now imagine Mount Rainier with its mud flows flooding the cities of Seattle and Tacoma, home to 2 million people. It's happened before. Between 1820 and 1892, Rainier had erupted 16 times. Then there were only a few settlers in the area. Today, if the same thing happened, thousands of lives will be affected.
Parts of Tacoma and Seattle are built on old mudflow deposits, and it's estimated that about 100,000 people live over those old mudflow deposits, and we know that they could happen again.
You might think, well, if we can figure out when it's going to erupt, we can begin to evacuate Seattle and the towns around there. But the problem is, we can't predict exactly when it's going to erupt. So what do? You're not sure if the eruption is going to happen in the first place. You're not sure how big the eruption is going to be.
It's an uphill battle for scientists, but with today's technology, scientists are more equipped to predict an eruption.
There's information in every single pixel about how much radar energy was reflected back, how bright it is.
An infrared technology known as INSAR uses satellites to capture ground images. Images that mean nothing to the untrained eye speak volumes to the scientist.
We take pictures from Earth-orbiting satellites and we turn them into beautiful patterns like this, which are pictures of how much the ground has moved. In this case, how much uplift there's been. In this case, how much the ground has subsided.
Another innovation that's become a vital weapon used by scientists, the Global Positioning System. GPS is a constellation of 24 satellites. Each satellite orbits the Earth at an altitude of 11,000 miles and continuously transmits information.
Testing signals that can be received on the Earth, and with a little bit of magic, a little bit of processing of those signals, you can determine where you are. If a volcano begins to swell, or a given station begins to move laterally because a fault is starting to move, we can see that.
GPS, I think, is the ultimate positioning tool for volcanology studies. It has the ability to get three-dimensional displacements. You can employ it as a continuous fixed site that gives you data every second if you'd like, or you can move the sites around. So this satellite is picking up those signals, and the signals are transmitted through the cable here down into this receiver right here. And the receiver logs the data, and in fact it stores it on a small memory card, just like what you'd have in a digital camera.
Even with tools like the GPS, there are still so many details about volcanoes that scientists are trying to uncover. Till today, no scientist has been able to determine the precise timing and magnitude of the next eruption. This unpredictable nature perhaps explains why there is great fear of the volcano. But could the volcano perhaps be beneficial to mankind? A mighty volcanic eruption often elicits fear. Death and devastation follow.
This moment, I honest to God believe I'm dead.
But not all volcanoes are violent and destructive. Volcanoes give us life and sustain our existence. This is another characteristic of a volcano. In Hawaii, the eruptions are gentle. They allow life to flourish.
Well, Hawaiian volcanoes, although they do explode every once in a while, usually erupt very quietly. They simply send out very fluid lava flows that can travel sometimes quite long distances.
Below the Pacific Ocean, underneath the layers of the Earth's crust, is molten magma. Over millions of years, volcanic eruptions underwater caused each of the 5 Hawaiian islands to be created. First, the volcanic eruption started over an area where molten magma rises from underground. This is called a hotspot. Over time, they rise above water to become an island. When the Pacific Plate moves, the newly built island is cut off from the hotspot. This island moves together with the Pacific Plate while the hotspot stays stationary. Over the original hotspot, new eruptions occur. This is Kilauea. It sits on the southeastern slope of Hawaii's Big Island. It is a shield volcano shaped like a dome with gentle sloping sides.
The Hawaiian volcano has a lifespan of around 500,000 years to maybe a little bit longer than that. Currently, Kilauea is just a youth. It's perhaps 250,000 years old. It has a long ways to go. But on average, probably 500,000 to rarely perhaps as much as 700,000 years or so. Geologically, of course, not long, but a huge time span in human terms.
Kilauea's main summit is the Halema Uma'u. Today, lava no longer flows from this crater, but make no mistake, Kilauea is an active volcano. It has been erupting almost continuously since 1982.
Before 1924, most of the eruptions, the previous 100 years anyway, had been occurring at the summit of Kilauea, and there was active lava lake here for almost a century. But in 1924, something about the system changed.
The eruption originally occurred at Kilauea's main summit. Then, magma stopped flowing because of a drop in pressure. Because of this, magma was transported to another smaller crack near the surface. This process repeated several times, transporting the magma eastwards through different vents. Kilauea's current eruption, called the Pu'u'o'o, originates from a vent away from the original crater. This eruption gives new life to the Hawaiian Islands. Lava that flows out of the vent reaches the ocean and solidifies. This eventually becomes fertile earth. These are the hardened lava fields of Kilauea. Jagged terrain dot the landscape as far as the eye can see, stretching for miles across the southeastern part of the Big Island. This is the field of nothingness. For now, only black rocks and blue sky sandwiched between heaven and earth. But with time, life will find its way back.
Hawaiian lava flows, of course, destroyed. They burn forest and buildings and so forth, but they're also very important in renewing the landscape and allowing vegetation to return in sort of a pristine state. Once in a while, explosions from Kilauea have showered volcanic ash on much of the very young flows on the volcano, thereby creating sort of an instant soil.
Among some Hawaiians, though, there is a different explanation for this cycle of life. To them, the eruption is the sole work of Pele, the goddess of fire. She is their giver of life.
Pele really is the goddess of volcanoes. She's embodied in everything volcanic that we see here, from the steam to the sulfur to the flows themselves. Pele's arrival has lots of different versions, but they all kind of culminate with the same story. Pele's travel from afar, from Kahiki, arriving first on Niihau Island, the northernmost of the main Hawaiian islands. She brought with her, interestingly, her sister, Hi'iaka, of the bosom of Pele. She has incredible regenerative powers. As Pele creates the land, Hi'iaka follows right behind, bringing life back to the landscape, bringing the plants and the forest that we see around us.
The gentle flows of Pele, however, should never be misconstrued. Danger can still lurk. In the past, lava flows had threatened to destroy homes and property. To the Hawaiians, they believe what Pele gives, she has a right to take back.
People that live here have perhaps more awareness and more respect for the volcanoes than people that don't live near them. And so certainly it's a part of everyday life, especially when you have a volcano that's erupted continuously since 1983.
The volcano allows life to flourish wherever its lava flows. Its erratic nature, though, sometimes puts it at odds with man. Can the volcano be controlled? With the help of science, can the volcano be reined in? History has always shown volcanoes to be the untamed power. But today, the picture is changing. There are ways to harness power from volcanoes. Iceland. More than half of its land is barren, and only a quarter of it is habitable. The rest of it is made up of ice sheets and lava fields. It is the land of fire and ice.
Iceland has got 30 active volcanoes on it, and also 11% of the land mass is covered with glaciers. During the Ice Age, the whole of Iceland was covered by glaciers, and there were active volcanoes under the glaciers. And this interaction between fire and ice has done a lot to form the landscape that we see today.
Iceland sits over a hotspot, but its volcanoes are different from the rest. These volcanoes are created when magma rises up between two diverging oceanic plates. They are called ocean ridge volcanoes.
The volcanoes in Iceland are very different, and that is because Iceland sits on the mid-ocean ridge. Well, most of the volcanoes along the mid-ocean ridges are quite linear. They form ridges rather than large constructive volcanoes. Because we're on a plate boundary, through time the volcanoes move away from the heat source. And so the volcanoes are eventually leveled.
Beneath the ocean, the North American and Eurasian plates pull apart, creating a gap and several small openings called fissures. These allow magma to rise up. When the magma comes into contact with water, it cools. Over millions of years, this solidified material begins rising above the sea, becoming a landmass habitable to man. This is how Iceland was formed.
Most of the magma that comes up, about 95% of it, is basaltic magma, which is the same magma that makes up the crust of the seafloor. And it's very hot and very fluid and very dense. And when it erupts, it generally, like the volcanoes in Hawaii, it flows away from either a central vent or a fissure.
A fissure is just like this. This is a fissure, a fracture in the Earth's crust. And up through these fractures, molten magma from the mantle is coming upwards through the Earth's crust and erupting.
Living in the midst of many volcanoes, scientists in Iceland like Omar Fridleifsson have devised a way to harness volcanic power. The shallow magmas that can trigger destructive volcanic eruptions have been the source of Iceland's geothermal energy.
Volcanoes, of course, generate a lot of heat. Okay, magma's coming up from the mantle or from the crust at a very high temperature, and whether or not that magma has reached the surface or is erupting at the surface, that heat is in the crust. And when groundwater seeps into the crust, it's heated up in the crust by this heat source and then rises through cracks and fractures in the earth. And that's where we get the geothermal heat in the form of hot springs and fumaroles around the volcanoes.
This geothermal energy has been tapped for almost a millennia, ever since the first man stepped foot on the island.
The first settlers in Iceland in the 9th and 10th century used those hot springs for bathing and cooking and washing their clothes, and gave great benefit to the people, especially in the cold Icelandic winters.
We are standing at the volcanic fissure from 2,000 years ago. The fissure extends some 15 to 20 kilometers across the center of the volcano and into the lake in the distance over there. Altogether we have some 23, 24 wells, and about 15 of these are used for steam production and for heat exchange with the cold water, which is pumped from the lake into the power plant. So the power plant is producing up to 120 megawatts of electricity.
Reykjavik, a city of 170,000. In this city, demand for energy is increasing at a fast rate. And to meet this demand, power from volcanoes is used to generate electricity. At the Svartsengi geothermal plant, 39 megawatts of electricity are generated. Two types of resources are harnessed, low and high temperature resources.
The low temperature resources in the field, we just drill wells or holes into ground, and we find hot water at temperature below boiling. This very geothermal water is then pumped into the towns where it is distributed to every home.
For geothermal water that reaches over boiling point or high temperature resource, it gets channeled through this heat and power plant. Here, electricity is generated and distributed to the residents of Iceland.
The difference between a conventional geothermal power plant and a resource park like we have here in Svartsengi is that a conventional geothermal power plant has only one product, electricity. In the resource park, we have many different products. Connected to it is the Blue Lagoon.
Surplus water from the plant goes into a nearby lagoon. The Blue Lagoon is a popular spa destination among Icelanders and tourists who believe that the water is mineral rich and has therapeutic and healing qualities.
The healing properties and the good effects of the water have become known internationally. It's very well known for its active ingredients, which are minerals that help us relax, silica that both cleanses and exfoliates.
The therapeutic Blue Lagoon aside, the benefits of geothermal energy are indisputable. 9 out of 10 homes in Iceland are heated or powered using this geothermal energy. This means a cleaner, cheaper form of energy. There is a great desire to harness the strength of the volcanoes. Not content to just dig 1 kilometer down, scientists in Iceland are planning to go even deeper inside the volcano.
There is now ongoing research and development program. We are going deeper down into the ground, where we find some, say, 500 degrees Celsius hot fluid, that's about 900 degrees Fahrenheit. Bring that fluid up to the surface and see if we can make use of it. And we expect that we may get maybe up to 10 times more energy out of one such well than from the conventional.
The Iceland experience has shown that volcanoes are not always the terrifying menace feared in history. But another breed of volcanoes, unlike any we've seen so far, lay silently to stoke their cataclysmic fires. These are not towering mountains, but low-lying calderas termed by scientists as supervolcanoes. As much as the volcano lets life flourish, it is easy to fear it. It is unpredictable. And its might is not to be trifled with. Its effects can reach thousands of miles away. History has shown the devastation caused by Thera around 1600 BC, Vesuvius in 79 AD, Tambora in 1815, and more recently, St. Helens in 1980. But imagine the eruption of a class of volcano that exceeds all these in magnitude and reach. They pale in comparison to the eruption of what scientists term as supervolcanoes.
Supervolcanoes are a class of volcanoes at the end of the spectrum. They're the largest, most explosive, potentially catastrophic volcanic systems on Earth.
These supervolcanoes are not tall, towering mountains, but calderas or craters in the ground. The time between these super eruptions can be as long as 100,000 years. This long time frame allows magma to build up, causing a cataclysmic eruption different from regular volcanoes.
Mount St. Helens in 1980 was a devastating eruption. 57 people died in spite of the fact that many people were moved away from the volcano. Roughly 1 cubic kilometer of magma erupted to the surface. The last time Yellowstone produced a caldera-forming event, about 600,000 years ago, 1,000 cubic kilometers of magma erupted to the surface. 3 orders of magnitude larger, 1,000 times bigger.
The last eruption of a supervolcano, scientists calculated, occurred 75,000 years ago in Toba, Indonesia. When this supervolcano erupted, it collapsed to form a lake we see today.
Toba was one of the largest eruptions that we have known since prehistoric man actually has been on this earth. We may have had a total destruction of its ecology. And that means that the early man that lived at that time in that area probably died as a consequence of this after effect. Only a few thousands of tens of thousands were left behind. And so we had this reduction in the number of people that had at that time already been living on the earth. Suddenly they almost came to be exterminated.
Unlike ordinary volcanoes, these supervolcanoes of prehistoric times were built differently. Supervolcanoes simmer for a long period of time without erupting. The magma accumulates into a large boiling reservoir for thousands of years. This reservoir increases to an enormous size, building up colossal pressure until it finally erupts through multiple vents. The result is an eruption that lasted not just a few days, but several months. The magma chamber then empties its contents. This supervolcano implodes and creates a huge crater in its place. Apart from Toba, there are a few of these supervolcanoes on Earth. Aira in Japan, Taupo in New Zealand. There is one scientists have been keeping a close eye on. This supervolcano is Yellowstone.
There are actually at least 4 calderas constructed at Yellowstone in succession that seem to be marching from west to east as a result of the Yellowstone migration of the North American continent over what is aptly referred to as the Yellowstone hotspot.
Will this mean that Yellowstone's cataclysmic blast is coming soon? Scientists won't know if it will happen within the next 10 years or the next 10,000.
The good news, of course, is that these end-member events, these largest of all volcanic eruptions, are very, very rare. Yellowstone last erupted 600,000 years ago. Long Valley about 700,000 years ago. And so the hazard right now, today, is greater from the many hundreds of smaller volcanoes which could erupt in our lifetime than it is from these catastrophic caldera-forming events that happen less frequently.
There are still so many unknowns in this quest to understand what goes on deep inside the volcano. As much as volcanoes have been a part of man's history, their study has only really taken off rapidly in the last 50 years. And it is only apt that mankind seeks to understand it better.
Humans are nothing else than volcanic products. And that may be very surprising, but let's think about it. Most of what we are is water and about 7 different elements. That water and those elements were almost all brought to the surface of this earth by volcanoes. They came from the deeper parts of this earth and they were brought via magma to the surface. And so the volcanoes actually are the base of the life cycle.
Volcanism is a benefit to us, but it can be a disaster too. And that's the message that we are trying to teach.
As destructive as the volcanoes can be, they are no doubt an intrinsic component of the Earth's life cycle. A cycle of birth, destruction, and then rejuvenation. With fertile soil, new forests are formed, providing a fresh slate for life to take place. History has shown us this, and we only know this after centuries of understanding it, after years of going deep inside the volcano.